Hi everybody. Tonight we have a problem that's quite similar to an SMO review type question. And that particular problem was kind of a tower power sort of thing. Okay, so this reads x raised to the quantity x to the fifth equals to 100, okay? And they wanted you to find the floor of x to the fifth, which was a little controversial, and it's kind of, to me, the floor part is unnecessary here because it leads people to believe that x to the fifth is going to be a non-integer, all right? And that's the floor of an integer is just an integer, so it's kind of an unnecessary operation if this resolves to an integer. But let's see how this works out. I switched it up a little bit, used 7 here. Now, it turns out that's sort of important because 196 is the same as 2 times 7 squared, all right? And up here, this is 2 times 5 squared. And so the 5 actually plays a role. And so let's see what that role is. Okay, let's move it along. Now, again, this is what I've already mentioned. It's kind of misleading because you're thinking x to the 7th can't be an integer. That's the sort of the intention of using the floor function, you know. Now, so another way of putting that is x to the 7th would be a member of this, what is it? Q is the rational numbers. So backslash the natural numbers. Okay, that's what we mean by a real rational or non-integer. You're subtracting all the natural numbers from the rational numbers, so to speak. Okay, now so let's look into the solution here. Now this is really fairly natural. It's a lot easier than you might think an open problem would be. If you'll notice what I did on this very first step, I just took the square roots of both sides. That's equivalent to raising both sides to the half power. Like, you know, if you have something in this form, a is your base, m raised to the n, okay, that's equal to just a raised to the product of the two values, m and n. Okay, you can always like to say, if you have n copies of m copies, you have m times n copies. Okay, so in other words, in this particular context, the m would be the same as x to the 7th. Okay, the entire exponent, which is something exponential also. And then the n in this case would be just 1/2. Okay, or it's a lot of times people just say take the square root of both sides, but really you're raising both sides to the 1/2 power. Okay, it's not normal, you don't think of it that way, but that's why we actually, you see, x to the 7th times 1/2 right here is exactly what happened. X to the 7th over 1/2, all right? Now, of course, the square root of 196 is 14, okay? So one thing that's super helpful in solving this problem is just to note, and I'll go ahead and write it, we can write it, I guess, in radical notation too, just for variety, but the 7th root of 14 squared, it's not squared, raised to the 7th power, excuse me, is just equal to 14. Okay, and just writing that down and examining this expression leads us to the conclusion that x must be the 7th root of 14. Okay, and again, it's very easy to check this. I'll go down beneath if you want. This would be the same thing as we're just substituting in the 7th root of 14 raised to the 7th root of 14, and that's raised to the 7th. It's a little weird, isn't it? So you got this, and then it's all over 2 still, right? So you see, folks, that would be, this is 14 over 2, which is 7, so that would be the 7th root of 14 okay, raised to the 7th power. All right, which is equal to 14. Now, so what was the question? The question was evaluate the floor of x to the 7th. Okay, well, the floor of x to the 7th would just be okay, there it is right there. So that's just equal to the floor 14. And that was the problem I had at the beginning of the problem. See, this is the answer. Okay. And again, it's just trivial. The floor of any integer is just the integer. So the answer is 14, which is weird. Okay, so again, I think the SMO people, maybe they were in a hurry here. I don't see a sound motivation for taking the floor. And again, this is a problem I made up based on this structure right here. This was the original problem 11 in a SMO Open review. And the answer here was the floor of x to the 5th equals 10. And it's trivial if you kind of look at it. It's just the exponent manipulation is a little uncommon and maybe slightly confusing. But anyway, that's just it. It's a little bit of a grievance, not a grievance, but a beef with why they would mislead you by using the floor. You know, you see that, you go, must be some number, some fractional number or some irrational number, and we have to calculate the floor also, when it's really just superfluous. It's unnecessary and leads to confusion. And so the problem itself was actually quite simple. All right, and so this was the answer to the problem. To me, a more natural problem is just to say, find the value of x. Okay, find the value of x. And if the value of x is just, for this problem would be x to the 7th root of 14. That would be a more natural answer than this circus right here. Okay, thank you.